So we're on page 18. You don't need your calculator out, but I just want to show you, we're going to learn the derivative of sine, cosine, e to the x, and natural log. Okay, so I just want you to brainstorm, and I know that this didn't copy very well, so I apologize. Real fast, if this is the graph of cosine, what would you say the slope of cosine is at 0? 0. So the slope is 0, so I'm going to put that point. Because this graph, I said, hey, let's go graph the derivative of cosine below. Boom. So the slope of cosine is 0 at 0. I just need you to kind of guess. I apologize. This isn't great. At pi over 2, anyone have any guesses what that slope is going to be? Negative what? 1. That's it. So you guys, again, I'm sorry that your copy didn't come out great. But at pi over 2, the y value is negative 1 of my derivative graph because my slope of cosine at pi over 2 was negative 1. Anyone have any idea what the slope of cosine is at pi? Back to 0. What about at 3 pi over 2? Yeah. And at 2 pi? We're back to 0. You guys, we got our little trend. Ooh, I heard it. What did someone just say? Not quite. Oh, what am I doing? Ooh, I heard inverted. So we're getting a little closer. It's not quite sine, is it? Because it doesn't start by going up from the origin. It goes down from the origin. Therefore, it's negative sine. Sammy, this right here is negative sine of x. So what you've just figured out is the derivative of cosine is negative sine. The slope of any cosine function is always negative sine of that angle, which is kind of wild. That's one derivative rule that we could write right here. The derivative, if my function is cosine, go on over to that next page. That means the derivative is negative sine of x. So if I were to say, ooh, I wish kind of. If I said, hey, if my function is sine, what's the derivative of sine? Check this out. Let me show you real fast. Sine is my blue graph. Oh, it's just cosine. The derivative is my red, which you said is what? Cosine. It's just cosine. So the derivative of sine is always cosine. The derivative of cosine is negative sine. Is that annoying? Yeah. This one makes up for it. E to the x is the best. You guys, grab your calculators. I'm going to let you see something. Let's go graph e to the x. So on your graphing calculator, if you could type in e to the x as your first function. Then the next one, I'm actually going to have you change it. Okay. I want you guys to hit, oh, never mind. Okay. On the next one, I want you to hit math 8. I want to take the derivative of, let's just go type it in again. Let's go type in e to the x. Get out of here. E to the x. Then it's going to say, well, when x is what? We want the whole derivative. We're going to say when x is x. And let's go look. How many graphs do you have shown? Weird. So the derivative of e to the x is what? That's the best one out there. I love e so much. The derivative of e to the x is just e to the x. Can we get any better than that? Fine. So we love e. We're going to say y prime is just e to the x. Instead of just like willy-nilly sketching this, let's think about this real fast. What points, and again, I apologize that this graph didn't come out great. It's from Desmos. What point would we have if I thought about when x is 0? Yeah, e to the 0 is just 1. My scale was up 5 there, just to give you a little concept. What about e to the first when x is 1? Anyone remember what e's value is? 2.718. So I'm going to go when x is 1. I'm going to go up 2.718-ish is about there. Who knows? Guys, then we can just draw our trend. You're like, okay, the derivative of e to the x is just e to the x. So I'm going to kind of match that other graph that I gave you. Okay, I did a typo here. Guys, I need everybody to get rid of this e here. I just want this to be a to the x. Or you could just rewrite this as just a to the x. When a is just a number. So we could give ourselves, let me actually tell you what the derivative is before we give it ourselves an example. The derivative of a to the x is still a to the x. We still love that, but we have to add in a little ln of a after that, which is annoying. let's talk about why I didn't have to do that up here when it was e to the x.
ln is 1.
So if I did that rule, if I did this exact same rule, e to the x, the derivative of e to the x is e to the x times the ln of that base. Ln of e is just 1. So I really am doing that rule, but we don't have to think about it since that ln of e cancels out. Let's give ourselves a little practice. Let's go say next to this guy. Let's say my y equals 9 to the x. What would be my y prime?
9 to the x times ln of 9.
Exactly. 9 to the x, ln of 9. Okay, as we look at this guy, natural log, actually, I'm curious if anyone could come up with it. If I give you the natural log graph, if I give you natural log, let's see if someone could think of it. Ln of x, oh gosh, clear that out. Boop, get out of there. Ln of x, here comes this derivative, math 8. The derivative of natural log is 1 over x, and you might be wondering like, well, where'd that x come from? It's this. This x went right there. And then this goes back to yesterday a little bit. Derivative of y equals 1x to the first. Just 1x to the 0, which would just be 1. Beautiful. I messed up my notation. I need you guys to say, here's what I forgot. We need to say f prime, the derivative. This is the formal definition of the derivative. I need you guys to go throw that limit notation right in front of it. Here's the problem. I typed this out once earlier when we did it. And remember, I don't know if you remember, I left it off then. Then I just did copy paste for all these separate ones. And so therefore I kept forgetting it. Gah! So the limit as h approaches 0 of this is the formal definition of the derivative. Over here, I left it off too. The limit, thank you, bud, as x approaches a. I left that one off over there. My Lanta. I want to look at this one first. And actually on all of these, my bad, we got to go through that limit notation in front. Limit as h approaches 0. Go ahead and throw that for all 4 of these. Ha! That's nice. Okay, so I want to look at this one first, you guys. Oh, wait, but I'm not going to zoom in because I want to see these definitions. You guys, which definition would you say this one uses? Are we saying it's going to be the blue Ken or the pink Barbie? Ken, right? I'm just Ken. Okay, they use this. And now AP is literally going to give you this question. And all that means is what's the derivative of the function? You're like, what? They're not going to give you any words. They're just going to give you this. And we have to know, oh, they want f prime. Hi, Mike. So we just have to remember that this means derivative. What? Now you're like, well, what function are they even talking about? You guys, if they gave us this, and here's the definition of the derivative. Where is the function? It's that x to the 4th, right? So here's what we got to think. You're like, what do they even want? Okay, they want the derivative. The derivative of what? Oh, the function is always the last thing. So what I would write if I were you is I'd say, okay, I know my function is x to the 4th. But then what they want is the derivative of that. So you're like, okay. What's the derivative of x to the 4th? Boom. You're done then. So you're like, if they just would have given me this question, I could have gotten that in a second, right? But we do need to kind of extract the info from this to spit out what they want. We can do this, though. We can do this. What if we look at one like this, though?
So it's sine of 3.
So we need to almost extract 2 different things. We first have to say what the function is. Then we're going to find the derivative of that function. Then we're going to plug in the x coordinate. So what would you just say the function is, not at a specific point? Sine of x. Let me say this. Ready? And this is the first time we've seen this. This is the first time we're seeing this. So if my function is just sine, and you're like, well, but wait, why didn't we do that before? They didn't ask it at a certain point before. Now they've plugged in an x value. We'll see it. Okay, you guys, what would f prime be if my function was sine? Maybe you got to go to that little chart. Derivative of sine is cosine every time. Then, do you agree they're asking for that derivative at a certain x coordinate. So this is when you'd say, okay, they want the derivative when x is pi over 3. So now we've got to go say, what is the cosine at pi over 3? Ooh, so close. That's at pi over 6. So it goes pi over 6, pi over 4, pi over 3. The x coordinate is going to be 1/2. Whew, this is hard. I think the hardest part is not putting in the x yet. You can't find that derivative yet. So what's my function of this one? Real fast, one more time. When you see this question, they're asking for the derivative of a function. And in this case, they're asking for the derivative of a function at a certain point. Whew. What's just the function do we think? Do you agree we used Ken's formula here? Because again, we got h approaches 0. But they plug in, look at my function over here. It's 1 over x, right? Because we got that whole 1 thingy up there. So my function is actually 1 over x. And you might be like, hold up, what are you talking about? Do you agree they did x plus h right here? Oh, they flipped it. I wish that was a 2 plus h. 2 plus h is my x plus h. So you want the derivative of 1 over 2 x when my x is going to be 2. Whew! You guys, we can't write this derivative, take this derivative yet. We got to write it as a power function. What's this just written as x to the power? If my function is x to the negative 1, whew, what's the derivative? Boop. Perfect.
Why is it x to the -1? And why is it 1 over x?
Yeah, bear with me. Stay with me, and then I'm going to come back to it. I want to just finish it, and then we're going to swing back around. Guys, I want us to rewrite this without a negative exponent. -1 over. Great. That's the derivative of my function at any x coordinate. In this case, where do they want that derivative? When x is 2. When x is just 2, if my function was 1 over x, okay? So they want that derivative just when x is 2. So I'm going to go plug that in, boop, right there. What would that get me? -1/4. Bondi, you had said, wait, why aren't we just taking the derivative of a half? What's the derivative of a constant?
0.
Every time. This right here, sine of pi over 3, that's just a constant. We'd get 0 every time if we just did it at that. So that, to me, is the hardest part. Extracting the function in terms of x when they've already plugged in something there. Great question, though, okay? Is 0 going to be one of their choices for multiple choice? For sure. Yep. Okay. Ooh, okay, I'm not going to zoom in because, again, I want us to see these formulas. You agree we use Ken because as h approaches 0 here. Okay? This is hard. If we just look at the first part, e to the h, what did they make our x value? Say it again. Is h plus 0 the same as h? Right? So you guys, my function here is just e to the x. Let me say this one more time, because you might be like, what are you talking about? Where'd they get this 1? Right. You're like, wait, why isn't my function just hanging out here? But you guys agree my x is 0 in this case because it was h plus 0. You agree with that? Well, if my function is e to the x and my x was 0, what's e to the 0? That's why they put a 1 there. Right? This is hard. So let me say that one more time. You agree this is the function up here. But if they wanted it at a certain x value, which we said was 0, they're going to plug that in. So what is f of 0? Wouldn't that be e to the 0, which is just 1? And they put that right there. So do not lose sleep on this. This is not big picture, I promise. I just want to show us some random examples. So if my function is e to the x, what do we love about e to the x? What's its derivative? Yeah, f prime of x is still e to the x. Where did they want that derivative? When x is 0. So we got e to the 0 is 1. That's my final answer. So I just jumped to page 20 on the bottom because I think this is a good segue from yesterday to today. If I gave you this as my h, and I want to know h prime of 0, I just want to first focus on h prime of x. Let's just first focus on h prime of x. We kind of started with this yesterday. You guys, if we've got that constant, let me give you an example. What if I said, you do not need to write this down. What if I said h of x is 5x to the 4th minus 6x squared cubed, sure, plus 2x to the negative 2nd plus 8x minus 10? Whew. Okay, help me out with that. You don't need to write this down. This is just a jogger, little mems. What do we say the derivative of this one is? 20x cubed, because you went like this, boop, minus nice, plus 8. Good. Yeah? Technically, right here, did we technically, to get this derivative, keep my 5 and say the derivative of x to the 4th is 4x cubed? Did we technically do that? We kept the constant, and then we just took the derivative of my little x to the 4th to get 4x cubed, and we multiplied them together. Great. So what does the derivative of 3 times f of x going to look like? Say it again. Yeah, you're like, okay, keep my constant. Take the derivative of f. Thank you, Greer. Minus, what's the derivative of 2g of x going to be? 2g prime of x. Here's something new for us. Minus 5 times the cosine of x. Keep that constant, minus 5. Anyone remember what the derivative of cosine is? Say it again. Negative sine. Derivative of minus 3 is 0. So you guys, are some of you going to jump, excuse me, right to a plus 5 sine of x right there? Yes, and I'm fine with that. But you don't have to. Okay, now they want h prime is 0. H prime is 0. Let's go plug in some knowns. 3 times f prime is 0 minus 2 times g prime is 0. I'm actually going to jump to that. Negative times a negative is a positive 5 sine of 0. You guys, how the heck am I going to figure this out? Did they tell us anything about f prime is 0?
Yes.
Oh, they did. Oh my gosh. F prime is 0 is 3. So we got a little 3 times 3. If you just write down a 9, good for you. Don't care. What about g prime is 0? Oh my gosh, they gave us that too. You could write down a little minus 14 or write it out. Ooh, back to our unit circle. Sine of 0. Zero's here. The y value is going to be 0. So we'd have 5 times 0. You could just write 0. Final answer? 0. Beautiful. So if we skip the top questions, we're looking at this one. Because this is not h approaches 0, I know that we're using my pink formula. And you agree in the pink formula, my function, boom, is right there.
Yeah.
Okay? And then they care about it when x approaches 0. They care about that derivative when x is 0. Okay, so here's my function. They're asking us what's the derivative of this function. Maybe we got to go back to our chart. This is not an e. This is a 5 to the x. This is an a to the x. So it's still going to be 5 to the x ln of 5. That's my derivative rule because on that front side we said, oh, the derivative of a to the x was a to the x ln of a. Okay? That's not an answer because where do they want that derivative? They want it at 0, and I knew that there. So I'd have 5 to the 0 times ln of 5. Say it again, Lai. Because anything to the 0 is 1. Oh. Okay, let's just try one more of these. This is it. This one they kind of gifted us. Look what they told us. They went ahead and told us what our function is. Ooh! They told us our function. What is this telling us that they're asking us for? The derivative. This is saying they want the derivative of f of x. That's what that's telling us. But they gave us f of x, which is so nice. But in AP, they're wondering, do you know that that's the formal definition of the derivative? So can you, oh, and I switched those around, you guys. I sure did switch that around. Oh my gosh. Okay, let's just focus on, this is asking for the derivative. If my function is sine, what's the derivative? Yes. Where do they want that derivative? At 2 pi. Oh, the x coordinate at 2 pi. All the way around gets us 1.